Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you? Okay, today we are going to continue. What I'll do, hopefully today we'll finish up the part on the second partial derivative. So hopefully, that will take maybe the whole of the period. And also, so now we continue from where we left last class. We look at the critical point. You have the critical point where the fx and fy is equal to 0. And that is true for either the function has a maximum or minimum. I think we already looked at the diagram, the figure on 14.4. So we're going to continue from there. And we're going to state the second, the second partial derivative test. So this is the test. Okay. Now that's the test. I'm going to write down the full name of the test. It's the second derivative test. Of course, it's partial, but I don't, I say I'm not right. Second derivative test. Now you have a function z equal to f of xy. So you want to find the maximum or minimum point of this function. Now, first, we find the critical point. Okay. Now, critical point is the first necessary condition. So find the critical point or points if there are more than one. Now, how do you get the critical point? So we're going to take the first partial derivatives. So to get that, you have fx equal to 0, fy equal to 0. So that would be the critical point. So in other words, you have to find fx, fy. All right. Now, when you have set that to 0, so that means what you have is a system of two equations. Okay, a system of two equations. So basically two equations like fx and fy. If you go back to the diagram, fx and fy, the horizontal line going along the y-axis and the other is going along the x-axis. You'll see here there's an intersection, and you need to find the critical point. So in order for you to find the critical point, what do? We solve the system of the linear function. All right. So that fx equal to 0, fy equal to 0 are two equations. So you have a system of two equations, namely fx equal to 0, call it number 1. And then you got fy equal to 0, we call it number 2. Now, given that system, you find the solution. So that solution would be the critical point. So you can have one or you have more than one, okay, depending on the equation. Sometimes you can have 2 or 3, right? So when we do that, we have the critical point. Now, let's say the critical point is at x0, y0. So the solution to the system is x0, y0, and that would be the critical point. So the solution is x0, y0. All right. Now, number 2, what we do is next, we find the second partial derivative. So number 2, we need to get the second partial derivative. And in order, or the use of that second partial, because you want to compute what you call the following. So now we define, okay, some function d, and that d is a function of x and y. That will be equal to fxx, function of x and y, multiplied by fyy, also function of x and y, and then you have to take away, or subtract fxy, which is also a function of x and y squared. So that is d. D is the difference between these terms, fxx multiplied by fyy minus fxy squared. So that is what we call d. And the value of the d, okay, the value of the d at the critical point will determine whether the function has a maximum or otherwise at that critical point. Okay. So in short, okay, you don't have to write something like this. This is a long one. So we can write in short form, we just call it d. Okay, equal to fxx multiplied by fyy minus fxy squared. So that is short form, easier for us to remember. So what you need, okay, in order for you to get the d, we need the second partial. Okay, so you need the second partial, which are what? Which are fxx, fyy, fxy. Okay, so those are the second partials that we need, and then put into the d, you get the d, and then evaluate that d at that critical point. Okay, so what you do next is that after you have the second partials, you have the d in that form, we need to evaluate the d at the critical point. So number 3, we evaluate d at the critical point, which is x0, y0. Okay. So you have d. Now you have a d, which is what? Which is a value, which is a number. So that d can be positive, can be negative, can be 0, right? So number 1, we consider d positive. So d positive, let's say d positive. So if the d is positive, so we'll say here d at the critical point x0, y0 is positive. Okay, now when that d is positive, you have a case, all right? We have a case for maximum or minimum. Okay, all right. So let's look at the test. I just want to check. Now I want to check that d. If the d is bigger than 0, we need to do this. All right. Okay. So if the d is bigger than 0, and all right, and fxx at that critical point is bigger than 0, and fyy at the critical point x0, y0 is also bigger than 0, then what do you have? We have the function, Okay, the function z equal to fxy has a relative, or sometimes you don't need to say the relative, minimum. Okay, minimum at x0, y0. So here, you need to look at three things. Number one, D must be positive. Okay, if D is positive, then what you look at is the value of fxx at the critical point, and also the value of fyy at the critical point. If both of them are also positive, then what is our conclusion? The function has a minimum at x0, y0. All right? Okay. So actually, that is for the minimum. Now, case number two. Okay, case number two, you have also the case of where the D at x0, y0 is positive, fxx at x0, y0 now negative. Okay, negative. And then fyy at x0, y0 is also negative. So you have what? Negative. So that means what? That means the function has a relative maximum. Has a relative maximum at x0, y0. Okay, I give you time to write down, okay, because this is not as straightforward as what we have earlier. Here, there are more than one value that you need to look at. First is the value of D. Second are the values of the second partial. Then only we can conclude whether the function has a maximum or minimum at that point. So I give you 1 minute, or 1 minute, sure, 2 minutes to write that thing. Okay, so right now. So make sure you write this, because it's not as straightforward. So what you do next is if, okay, if the third case is if the D is less than 0, and the last possibility would be if the D is equal to 0. So what happened? Okay. But the most important part will be these two things. Okay, this part here is the most important, because that where you have a maximum or minimum. Okay, all right. Now, case number 3, when the D is negative. Okay, if D is negative, then we don't have to proceed with the test, because it will not be maximum, it will not be minimum. Okay, so you may have what? You may have a saddle point here. So if D is negative, you may have a saddle point. Okay, saddle point at x0, y0. So this one, we stop here, right? You cannot, we don't proceed anything else. And the last case would be if the D is equal to 0 at the critical point. And then again here, we cannot say anything, okay? We cannot say whether it's a maximum, whether it's a minimum, or saddle point, with no conclusion. But this thing, case number 3, case number 4, is not important. Most important is 1 and 2. If your D is less than 0, then you say you have a saddle point, that's it. And if the D is equal to 0, then again, we cannot say anything, okay? So the one that is most relevant would be the one that you have the case where what? Where the critical value or the value of the D at the critical point is positive. Okay, all right, good. So let's look at some examples in order for us to show maximum minimum. So we are now in 14.4. So look at example number 1. All right, look at example number 1. So example number 1, you have that function. So you want to find whether the function has a maximum or minimum at the critical point. All right. So let's do that example. First is example 1. So you have the function equal to what is given there. You want to find a relative maximum or minimum. Now, first, what you do, you find the critical points. Right? Find the critical point or points where fx equal to 0, fy equal to 0. Okay, so that is the first thing that we need to do. Now, what is fx? Okay, what is fx for that system or that equation? What is the fx? It's equal to what? It's equal to, you have, a very simple additive terms. So you got x squared, so that becomes 2x, and then you got the negative 2x, that will be 2. Now, that, call it number 1. Okay, before that, you don't do it. You don't do that again first. Then you find the fy. What is fy? Fy is you have only y squared, so that will be 2y. Okay, set that to 0 for critical point. So I have a system of equations, right? So you have a system here, which consists of 2x minus 2 equals 0, call it number 1. And then you have 2y equal to 0, call it number 2. And very simple system, very straightforward, you get the solution. Okay, all right. So what is x? So from number 1, what do I get? I get x equal to 2 over 2, that is equal to 1. Now from the number 2, what do I get? I get y equal to 0. So the critical point is xy. Okay, I think I am going to write x0, y0. So that is equal to x0, that is equal to y0. So you know already x equal to 0. Oh no, x equal to 1, y equal to 0. So next you find the value of that 0. So substitute into the original function. If you do that, what you get is also 0. Okay, so the critical point will be what? Will be x0, 0, 0. Okay, but when you need to find the critical point, you just need x0, y0. So x0, y0 is equal to 1, 0. Okay, you sometimes you don't have to write the value of the z, okay, because the value of that z is the value of the function at the critical point. Because we need to get the second derivative or the value of the d. Okay, all right. So next, what you do, you get the second derivative. Now, what is the second derivative? Fxx, and then you need fyy, and then you need fxy. Okay, so what are the values of fxx? Okay, you get for me fxx. What is it? Okay, what is fxx?
2.
Fxx is 2. Now, what is fyy?
2.
2 also. What is fxy? fxy. You differentiate
0.
with respect to y. There is no y in that equation, so be 0. Okay. So what you have, number 2. you know that the D is equal to what? Equal to fxx, fyy minus fxy squared. So what do we need? We need fxx. Fxx equal to the derivative of 2x minus 2, that will be 2. Now fyy, derivative of 2y, that is also equal to 2. Now fxy, because you get fxx is equal to 2x minus 2, there is no y, so everything is a constant, so you got 0. All right? So what is the D? So D is equal to 2 times 2 minus 0, 0 squared, which is also 0. Lah. So that is equal to 4. Now you got 4. Now what about 4? Is it positive or is it negative?
Positive.
Positive. Lah. So you got 4 here is positive. Now when that D is positive, you have a case, okay? You have a case whether you have a maximum or minimum. So you got D bigger than 0. And then you look at fxx. Now, what happened to the fxx? If you look at fxx, what is the value? The value is equal to 2. And that what? What is it? That is a positive. And then fyy is also equal to 2. That is positive. Now, the reason why I put here D equal to 2 times 2 equal to 4, because it's a constant. But you have to remember, what we mean here is that you evaluate, okay? You evaluate the D at equal at the point x0, y0. So in order to make it formal, but you don't have to do that because everything is a constant. So I just add, okay, add to make it complete. So at x0, y0, which is equal to 1, 0. Okay, 1, 0. Then the value of the D is the same because it's constant. It's equal to what? It's equal to 2 times 2 minus 0 equal to 4. And that is positive. Okay. So what you get will be, okay, what you get will be something whether it is a negative, it's a maximum or it's the minimum. All right. So I have the D bigger than 0. And then you look at what? I look at fxx. Fxx equal to 2. And 2 is positive. And then I look at fyy. What about fyy? Is equal to 2. And that is positive. So you see here, D is positive, fxx is positive, fyy is positive. So therefore, what can we say about the function? So the function z has what? Has a relative minimum at, okay, at 1, 0. And of course, now, okay, we can already get the value of the z. So number 3, you find z at 1, 0, at 1, 0. So we know that z is equal to 0. So the maximum point is what? Is 1, 0, 0. So if you look at the, I don't know, it's not 1, 0, 0. Oh yeah, 1, 0, 0. So you look at the diagram in figure, in the example 1, or is example 1, okay? That's how the curve look like. The minimum occur at 1, 0, 0. So the minimum point is at, the minimum is at what? Is at 1, 0, 0. So we can say that the function has a relative minimum at 1, 0, 0. Okay. All right. So that is that's where you get a minimum. Now you look at example number 2. Okay, you look at example number 2. Here you have a saddle point. So for if you want to see how saddle point look like, it look like the figure 14.1. Okay, 14.1, you look at the figure that is saddle point. So from one side, it is a maximum. From the other perspective, it's a minimum. So that is a saddle point. So if you look at the saddle point, example 2, the D is negative. Okay, D is negative at the critical point. So you cannot conclude anything. I mean, we conclude that you have a saddle point at that value. Okay, all right. So now, okay, now we move on to another example, because the first example is a very simple system, but sometimes you may have a system, a linear system of a linear equation. Sometimes you may have a system like in the example number 3. So let's look at another example. Okay, 4x, and then so that's a 4x, and then 2y. Okay, so consider this example, and then we come back to example number 3. So here is example number 3. Okay, example 2 is the one that I want you to look at the saddle point. Okay, so you go home, go check that again. Okay, the third example, I'll give you this example, and then we go back to example number 3 in the book. Now, suppose I have the following function: z equal to f of xy equal to 2x squared minus try aja lah. Okay, try. I think we should get the answer. Minus 4xy plus 3y squared minus 15y plus 7y. Okay, that 15 is not y, should be x. Okay, so that is the equation. Now I want you to find, okay, find first the critical point. And then you have a system of 2 equations or points, and then solve the system. Now the system you already have. Okay, we already learned how to solve a system of equation. So not difficult. It's just that you have to spend time in order for us to find that solution, okay, to the system. So I want you to just now, okay, find the critical point. Let's work out the critical point. Okay, so do it now. Okay, you got the first partial. Okay, what is fx? Anybody got fx?
Fx tu 4x
Yes.
tolak 4
No, no,
kuan.
no, 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 say in English, okay? Because we are not the
Oh,
only
sorry,
people.
sorry.
We have people who don't understand bahasa Melayu. Okay.
Okay,
Now,
sorry.
what is fx?
Okay, fx equals to 4x
4x
minus 4y
minus 4y
minus 15.
minus 15. Okay, so you got that. Okay, that is the fy. Okay, now what is f? No, I'm sorry, fx. What is fy? Okay, xy minus 4y plus 3y squared minus 15. Minus 15, yeah, minus x. And then plus y. Okay. So what is fy? So fx is equal to 4x minus 4y minus 15. Okay. Now, what is fy? Anybody get fy?
Minus 4x plus 6y plus 7.
You got negative 4x plus 6y plus 7. Okay. Okay, good. So you have fy equal to, you know, the term is negative 4xy. So take derivative with respect to y, you got negative 4x plus you have 3y squared. So that would be 6y. And then I have a 7y, that would be plus 7. Okay? Correct. Now you rewrite this as a system of equation by equating it to 0. So find the critical point, you know fx equal to 0, fy equal 0. So rewrite it. Okay? Rewrite it again, set that to 0. But I do not write again. I just put here equal to 0 because, you know, save my time. So you got equal to 0 here, equal to 0, that call you number 1, call it number 2. But sometimes, you know, if I do, that's the thing. That's why I ask you to write again, because this may be confusing. Because you have the fx, I have the fy, and then equate to 0. So that can be confusing. So that's fine. I will write again. So you set that to 0. Okay. Set that to 0. You have a system of 2 equations. So I want you to find the solution to the system. And that solution would be what? Would be the critical point. So we know how to do that. So I give you a few minutes to do that. So you have a system 4x minus 4y minus 15 equals 0, call it number 1. Sometimes, you know, to find the critical point, that takes some time because you need to work out how to get that point. And then you have the fy. Fy is equal to negative 4x plus 6y. So negative 4x plus 6y plus 7. So that is our equation number 2. So here you have a system of linear equation. So not so difficult to find. All right. you bring the constant to the, so you just do by substitution, or you can just do by elimination, because you have maybe you eliminate the x, it'll be easier because you have a plus x minus x. You do by substitution because that's the method that we learn. So you put in the thing, and then get the point. Okay. Anybody who get the point, tell me. Okay, you got the critical point, the solution. I mean the solution lah. X0, Y0. Huh. You get the value?
Sir,
Yeah.
I got negative 3.5 and 0.25.
Okay, what about anybody else? Because I get a different value, I'm also working on it. I got a different value than yours. So I will check again, whether I was wrong or you are wrong. You got 14x minus 4y minus 15 kan, betul lah tu, minus 15. Then I have negative 4x plus 6y plus 7. Tunggu je, 4x or okay. Anybody get the same value as her, or you got a different value? Because myself have a different value. So now I'm not sure whether I was right or she is correct. Anybody else ever has an answer?
I got y equal to 4, x equal to negative 31.
Negative 31. Okay. Y equal to negative 31. That one is closer to mine. Sekejap ya, tengok balik. So you masukkan balik 4 times 4, 16. Okay, anybody else have get the solution? Check balik tu. Yang you kata 31 tu, check semula. I got the y equal to 4. But the x is not 31. So the, siapa yang mula-mula tadi, yang dapat mula-mula tu?
Sir, saya kira balik jap.
Kira balik, check balik. Sebab saya pun dapat y equal to 4. Lepas tu I got x, but my x is not 31. So siapa yang second tadi tu, yang dapat y x equal 31?
Me.
So check balik. Check balik, masuk balik dalam tu, is it 31 or is it a different number than 31? Okay, anybody else will get the solution? Now, this is a system of linear function. Kita dah buat dah first topic. So ini, I think, this is another practice. So we should be doing this very, very quickly. To get the answer wrong, that's fine. But the thing is, we have to know the method. Okay, don't know the method. The method is, what we learn is method of substitution.
Sir, 7.75.
Yeah, x should be 7.75. Y is equal to 4. X 7.74. 7.75. So that 31. Okay, I think you forgot to divide by 4 because you have 4x. Okay, so you divide by 4, you got 31 over 4. That is 7.75. So what you do? Okay, we do by substitution. So here from number 1. All right, from number 1, you have what? I have 4x equal to 4y plus 15. And then you bring the 4 to the other side. I just write it right away. Divide by 4. All right, so you got x in terms of y. And then what you do next, you substitute into what? Into number 2. Okay, so what you got will be what? Will be negative 4, everything multiplied by 4y plus 15 divided by 4 plus 6y plus 7 equals 0. Okay, so you work this out. So you got y equal to 4. And then from here you substitute into, to make it easier, okay, you substitute into this one because you already have x. So I think here you got divided by 4. So you got 31 over 4. You work that out, you got x equal to 7.75. Now, if you got this wrong or you have not finished, I want you to go home, finish it up. Okay? Finish up this one because this is the linear function. We should be doing this in no time. Okay? If we take more than 10 minutes, I think we have to work harder. You have to spend more time doing things. If we don't do anything, then we are in trouble. All right. So that is the critical point. So critical point is x0 equal to 7.75. Y0 is equal to 4. And of course, here you find z0. Okay, find z0, substitute into the original function. Put into z, okay, the original one. So what you do now, you have the critical point, there is only one. So what we do next is that we get the second partial. Okay, so now let's go find the second partial. So you got fxx, so number 2, you got, so you write down number 2. Okay, number 1, we label. Number 1 is getting the critical point. So I got the number 1. And then number 2, you got to find the value of the d at the critical point. So in order to do that, you need fxx. Okay, fxx is equal to what? Is equal to 4. Again, it's a constant. And then you find fyy equal to 6, a constant. And then fxy equal 0. Right? Now, given d is equal to fxx times fyy minus fxy squared, that will be equal to what? Be equal to 4 times 6 minus 0. All right? So evaluate at the critical point at 4, 7.75. Now you find the value of z0, okay, whatever the value is. Or I think for now we don't need that z0 because we want to evaluate the d. Okay, we need only x and y. So at that point, d is equal to what? D is equal to 4 times 6 minus 0. That will be equal to 24. Now that 24 is positive. So positive, you know, is the first condition, okay? Positive first condition for maximum or minimum, all right? So again, here I have fxx positive equal to 4, that is positive. Fyy equal to 6, and that is positive. So what? So the function that has a minimum at, okay, at the critical point. So for 7.75, okay, now you can put in the value of z0. Okay, whatever you got, that will be the value of z0. If you have found, you put the value. If you don't, then you find it later on. Okay, all right, good. Okay, now we're going to look at another example. Now, example 3 in the book, that is, okay, that's that example. Okay, that example is good because you have more than one critical point. Okay, so you have more than one critical point. So we need to evaluate the D at each of those. So here, okay, so if you have 2 or more critical points, then what you do, okay, critical points, then you will repeat the test. Okay, repeat the test for each of them. Okay, for repeat the test for each of the critical points. Repeat for each of them. Okay, for each of them. Now, when I say repeat, you only repeat step number 2. Okay, so you repeat only step number 2. That means the D. Okay, the critical point. Sebab critical point kita cari. Okay, critical point you already have. All right, what you need to do here, we want to show the first point is a maximum or minimum, and then the second point, maximum or minimum. Now, let's look at that example. So we will look at the book. Then we look at the book. What I want to establish is just that there are more than 2 critical points. And then the fxx is not a constant. Okay, the fxx is a constant. So what do we do? So look at example number 3 in that book. Actually, example 4. Okay, because example, I give you another function. So if you look at that function here, okay, number 1, you have the fx, you got the fy, and then you set to 0, okay, So you set to 0 for the fx, you'll see you got 3x squared. Okay, this is I'm not going the full step. Okay, I will just highlight the one that is needed for us to discuss the things that is important for this function. So you got 3x squared plus 6y plus 24. Okay, so we call that number 1. And then I got fy is equal to what? 2y plus 6x. Now set that to 0. Set that to 0 also. So number 2. So you see here, you don't have a linear function. All right, you have a linear in x and y. The other function is x to the power of 2 plus y. So you have the two variables appear in both of them. So now, how do we solve this type of system? How do you solve? So you look at one of the equation, try to write, okay, try to simplify that, okay, and then use the other equation. And the method may not be the same as what we learned earlier. Okay, for this one, where should we start? We should start from what? From number 2. Okay, if you start from number 2, then you have x in terms of y or y in terms of x, and then substitute into number 1, so that you only have one variable. So from here, okay, so from here, what do I get? I get 2y equal to negative 6x. That means y equal to negative 6 over 2x. That will be negative 3x. So I got y equal to negative 3x. I put into number 1. So now I have for number 1, you have a quadratic function in terms only of one variable, which is what? Which is y. Okay. 2y equal to 6x. Y equal to negative 3x. I'm sorry. You put y in equal to negative 3x, and then you have the equation in one only in terms of one variable, which is what? Which is x, not y. I'm sorry. X. So let's do the substitution. So what do we get now? Okay, you just look at that example. Everything is given, but I just highlight some points. So now what you get will be 3x squared plus 6y. Now y is negative 3x. So you put in negative 3x plus 24. Okay, and that is equal to 0. So what do I get? I get 3x squared minus 18x plus 24 equal 0. So here, the book, they factor out the 3. Okay, so you got 3, you got x squared minus 6x plus 18. So we just follow the book, factor out. So now what you do, you find the roots, okay? Find x for which the equation is equal to 0. So you look at the formula. If you're not sure, you look at the formula, x equal to what? X equal to negative b plus or minus the square root, whatever, divided by something. So check that. Now this one is very important. So make sure you check. If you understand the, if you know the shortcut method, you can do that. But don't use calculator. Okay? Use calculator is easy, but you don't know what you are doing. So it will be not accepted. All right? If you just give me your answer in using calculator, how you get it? Okay, using calculator. So, but the thing is, you need to know how we got it. So make sure you know that formula. So what you get will be what? Will be, if you do that, I get 3x minus 2 x minus 4. That is equal to 0. X minus 2. So here you have x equal to 2, x equal to 4. So here you see here there are two values of x. So there will be two critical points. All right, so there will be two critical points. So now what you do, you need to find y. So firstly, at x equal to 2, all right, what is y? So to find y, what do? You put into, you put into the system back, all right? Either you put into 1, okay? Either you put into 1 or you put into 2. Now, which one is easier to do? Of course, okay? You put into 2 because 2 is what? I have 2y equal to negative 6x or y equal to negative 3x. So we make use of this relation. Y equal to negative 3x. So I got y equal to 2, x equal to 2, and then what is y? And you know y equal to negative 3x. All right? And that is equal to what? It's equal to negative 3 times 2 equal to 6. And how do you do that? We do that by substitution. Okay? So that is 1 point. When x equal to 2, I have y equal to, I'm sorry, negative. So I missed that negative. So you see here, you need to be more careful. Sometimes, we tend to miss the sign, which I also did here. Okay. But I missed the sign, but I didn't miss the work. Okay. The work is more important. Of course, the answer is also important, but the work is important. Okay. So you look at the second one. Now at x equal to what? The second value is x equal to 4. Okay, at x equal to 4, what is y? Y is equal to negative 3 times 4. That is equal to negative 12. Betul, negative 12. Negative 12. Again here, by substitution. So you find the value of z. Okay, at here you find the value of z. And over here, you got the value of z. So if you look at the example, you got already 20 and 16, okay? 20 and 16, the value of z. So you have two critical points, okay? So you have two critical points. So that means when you do the D, the second part, you have to do it twice for each of the points, okay? All right. So now step number 3, we know that the D is equal to what? Is equal to fxx multiplied by fyy minus fxy squared. Okay, so now what do we need? We need fxx. Okay, what is fxx? Go back to the system or to the first partial. You got 6x. Okay, you differentiate fx with respect to x. I got 6x. Okay, and then fy. Differentiate fy with respect to y, what do we get? We get 2. Is that right? With 2. And then fxy, differentiate fx with respect to y, what do we get? We get 6. So you see here, okay, which is different from the earlier examples, we have one of the second partial, it's not a constant. Okay, it's a function, it's a variable in terms of x. So you have to evaluate, okay? You have to evaluate at each of the points. So now, okay, so now what you do, you will get D equal to what? 6x multiplied by 2 minus 6 squared. Okay, minus 2 here. And that is equal to 12x minus 36. So 12x minus 36. That would be our the value of D. Correct. So you see here, the value of D will depend on X. So now you find the value at each of the points. So number one, at the first point, okay, what is the first point? At 2, -6. Of course, you can put the value of Z. Then what is the D? D is equal to, so now here, depending on the value of D, that is where you have to substitute. Okay, substitute the critical point, the value of X, value of Y, into that D. Okay, so what do I get? I get 12x, which is 2. Okay, minus 36. And what is it equal to? 24 minus 36. That is -12. So that is less than 0. Now, less than 0, what happened? D negative. What do we have?
Maximum.
No.
Saddle point.
Saddle point. Okay. So check again the test. You know, first condition for maximum or minimum, D must be positive. Okay. If the D is negative, then the function has a saddle point. Okay, saddle point. The one that is positive or negative will be the second partial. Saddle point at 2, -6. And of course, now you can put the value of Z, which is, if you look at the book, that will be equal to 20. So that is a saddle point. Okay, saddle point. You imagine saddle point that is given in 14.11. So that's how a saddle point look like. So now you repeat the test for the other point. Okay, what is the other point? The other point is berapa tu? 4
For -12.
for -12. So at 4 -12, okay, then what is the value of D? D is equal to, you know, D is equal to 12x minus 36. 12x minus 36. So 12 times 4 minus 36, okay, which is 6 squared. So that is equal to what? That is equal to 12. Okay, 48 minus 36, 12. And that is positive. So when you have a positive, then, okay, then you have a maximum or you may have a minimum. That will depend on what? That will depend on fxx. Okay, now fxx is equal to what? Fxx is equal to 6x. Okay, now you have to find the fxx at that point. Okay, so fxx, so I think I'm going to write clearly, fxx is equal to 6x, and then at 4 and 12, 4 and -12, fxx is equal to 6 multiplied by 4, which is 24. And that is positive. All right? And then fyy is just a constant, which is 2. So no problem, that will be positive. Okay. All right. So therefore, what is our conclusion? Do we have a maximum or minimum?
Minimum.
Minimum lah. All right. So you look at the book, the conclusion is minimum. Okay. All right. So here, first condition is that our D must be positive. And then you look at fxx, you look at fyy. Okay. All right. Now, I want to just for just to see how we evaluate. Okay, we evaluate the D at the critical point. So I'll give you another example. Now, this example, there is no function. Okay, there is no function. I just give you the value of fxx, the value of fyy, and then the value of xy. Okay, all right. So now, this is example. This is just imaginary example to reinforce our understanding of the computation of D at the critical point. Suppose our fxx is not as simple as what you have earlier. Suppose fxx is equal to 2x plus 4y. That's an example, okay? And then fy is equal to 2y squared plus x. All right? And then fxy. Okay, you don't question me anything. Maybe this thing doesn't add up, but I just want to see how I want you to see, okay, how we compute the D. And then let's say fxy is equal to x times y. Okay, so here you will see xy everywhere. All right. Now don't worry about that. First thing that you need to do is you compute fxx, fyy minus xy squared. Okay. Now suppose there are two critical points. All right. Suppose critical point is 1, 2, 4. The other one is 3, 5, 20. Okay. So what you do now, we evaluate the D at each of these. So at 1 and 2, at the first critical point, what is D? So now you put in, okay, put in the value of the x and y at the critical point, which we are testing, into the D. So don't worry how the D look like. You substitute the value of the xy at the critical point to the D. Of course, the critical point that we are testing. Okay. So what is D now? D is equal to what? I don't break out the bracket. Okay. I just want to see how we do the substitution. So what do? I have 2 multiplied by 1 plus 4 times what? 4 times y. What is y? 2. Okay. And then I got another term, 2y squared. Now what is y squared? 2 squared plus x. What is x? 1. So that is the whole thing. Minus, okay, xy. Xy is 1 times 2, everything squared. So here you see, you don't worry about the D. How many x will be there? What is the form of the D? It can be constant, it can be variable. The thing is, when you evaluate at that particular point, you have to substitute the value of the x and y into the D to find it. Okay? So you see here, I have the fxx, fyy, fxy, everything has x and y. And it looks very long, but it doesn't matter. What you do, you substitute. Okay? Substitute the x and y into that. Okay, so you got the value of D. And then when you want to find the fxx, what do? So suppose you got the value, and then fxx, I write here, okay, because I cannot see that fxx. So fxx equal to what? At 1 and 2 is equal to what? Equal to 2 times 1 plus 4 times 2. So that is equal to, ini senang kira 10. Okay. Now what is fyy? Fyy is that function at 1, 2. What do I get? I got 2 times 2 squared plus what? Plus 1 equal to berapa ni? 4 times 2. 4 times 2, 8. 8 plus 1, 9. You see? So you have to substitute again. If everything is constant, simple lah, because it's the same everywhere. But if the fxx, fyy functions, not non-constant function, that means they are variables. So what do? We have to substitute back the critical point where you are testing into those second partial. Okay. All right, good. So now what you do next will be, so you make the conclusion here. Okay. What you do next will be you test the second point. All right. Test the second point. Okay. Any question about that? Okay. This one has nothing to do with any function. Okay. This one is only to see an example where D is not that simple. D consists of X and Y. All right. But don't worry. What you do, you just substitute. Okay, substitute the critical point. So what I want you to do for this example, you finish up for the second critical point. Okay, so finish it up. Okay, any question? This part here is not that simple because saya pun pening kepala. All right, so I am going to stop here. And that's it for today. Now, I give you some questions, okay, for your practice. Question ni good for your practice during the long holiday sampai Sunday. So what you do, you look at 14.4, okay. So here you just do the second derivative test, all right. You do as many as you want, all right. Do as many as you want until we feel comfortable with the test. Okay, so make sure you know the test. That means the D. All right. Okay. So here I want you to do some of the questions from number 1 up to number 12. These are good questions, Actually, not number 12. Kita hentam lagi. To number 16. Okay. So you do as many as you want, but okay, do combination, all right? Combination of, you look at the equation, some of the equation, you will get the value of the partial, will be not just constant, will be, will be a variable. Then that will be harder to work on. So you look at some simple question and then do the more difficult question. Like example number 3 tadi lah. Okay, good. Now any question? So I think we'll stop here. So the test, all right? The test, because of the importance of the test and because of the length of the test, and the tedious work that we need to do, in order to complete the test, we spend the whole period. Okay, and that is worth it because actually the new part is on the second part. The first part we know, okay, the system of linear functions or linear equation we know already, so nothing new with that one. The only new is the second part. So I give you some questions. I hope everybody will practice that before Sunday. And then on Monday, we'll look at application. Okay. So by Monday, we'll look at application. That will be, I think, there is another one that we need to look at. Chapter 14, there is another part. So we're going to look at on Monday, application. And maybe we need another period on Wednesday to look at that last part. Okay, all right. Any question? Anything? Okay, so kita stop. We stop here. I will see you again on Monday. Any question that you have, okay, you can put in the WhatsApp group or WhatsApp group lah. Okay, because if you email to me, sometimes I tengok email pun jangan-jangan enggak. So WhatsApp group is the easiest way. If you have any question, put in the WhatsApp. And don't WhatsApp me personally. All right. If you have question, put in the group so that you can share with other people. Okay. All right. So I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Thank you, sir.
Masa ni, okey. Masa ni lah saya dengar suara orang ramai. Okey, semua cakap salam kat saya cepat-cepat. Saya nak dengar suara masing-masing.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you. Welcome.
Sir.
Gerak dulu, sir.